I can hear you. I don't know if you can hear me. Can you hear me? Are you there? Can you hear me yet? I'm assuming you still can't hear me. Any chance you can hear me now? Oh, perfect. Okay. I don't know. I'm using my son's computer and I have no idea what was going on. I think I fixed it. Okay. So, can you see what's on my screen? Can you see a lesson that says set one? Okay. So, what I need you to have out is your periodic table. Do you have that? And then do you have the sheet? You'll have to bear with me because I'm trying to do this remotely, so it's kind of funny. Do you have that sheet out? Okay, perfect. So remember that we will always start in the box that says decomp and synthesis. We'll always start there to figure out if we need to complete. And then if it's not one of these criterion, then we either go here, okay, and we go to this box here. Let me see if I can get my pen to work here. Uh, I got a new toy. I got a digital tablet that I'm trying to learn how to use. Okay, so we'll go here if it's, we think it might be a single replacement reaction. And we'll go down here if we think it's a double replacement reaction. So those are the two places we'll check. Okay, and so remember that a single replacement reaction is going to be some kind of element plus a compound, and a double replacement reaction is going to be a compound plus a compound. Okay. Okay, so that being said, let's get started. I'm going to go back a couple pages on my screen. So we'll start with 14. All these are the same kind of problem. So would it be okay with you if I recorded this and then I can send it to you and you can practice and hear what we talked about? Would that be okay with you? Yeah. Okay, so I will do that then. Let me get that set up. Oh, you don't need to worry about the page. I don't know which page it's on. It might be completing 9. You can try and see if it matches up. So it might be completing the reaction 9, not balancing 9, but completing the reaction 9. You've probably already done it, but it's the best thing I have to go over things together. So you don't necessarily have to be in the page. You could just be notebook paper. And if I send you the video, then you'll have the different problems to try before you try your quiz or your test, if that works. That makes sense? All right, so as I look at 14 here, or this first problem, I have a compound plus an element. So we're always going to look here first. We'll always check here first. So these are just compounds, so that wouldn't work because we have a compound plus an element. But we might check one of these 3. So what we're looking at first, every time, unless it's combustion, every time you'll start with this box. And you'll sort of eliminate if it's one of these choices. If it's not, you'll go here or here depending on, and let me show you that. So here we have a compound plus a compound, so it can't be that one. XO plus H2O is a compound plus compound. So here we have compound plus element, right? So it could be that one. So let's go back and look. It has to be, let me show you what I mean. It has to be something with chlorine, a metal with chlorine plus an oxygen to be that specific one. And we don't have an oxygen. Do you see that? Yeah. Okay, so then, and I'm going to be flipping to the screen a lot. So then once we say, no, it's not this space, then we go here if it's an element and a compound, or here if it's 2 compounds to check next. We observed that it was an element plus a compound. Agree? Yeah. Okay, so I want you looking at the arrow 1 on your paper so I don't have to go back and get you so confused. Okay, so now we have to think about who's alone. So sodium is alone, meaning it's the element, pardon me. The element's going to try to kick out something in the compound. Okay, and sodium is a metal, so it has to kick out a metal in this compound, or try to. So sodium's going to try to kick out nickel, because both sodium and nickel are both metals. Does that make sense how we know they're both metals? Yeah. Okay, so then we're going to see if it can. So look on your arrow chart and see if sodium is higher. I'm trying to find my arrow chart. Oh, it's on the floor. Give me a second. Yeah, it's higher. Okay, so sodium is higher. So it does kick it out. So it's kind of like it wins the battle. So then on this side, you're going to put sodium with the thing that nickel was with, so sodium with carbonate, and then nickel by itself. Does that make sense? Right, right. But you can't just replace. You got to crisscross, reduce, and Brinkelhoff. So we got to think about, once we build new relationships in chemistry, we got to think about how do they go together. So this is a +1, and this is a -2. I don't have to worry about this in terms of charge because I'll do something else with that. So let's first deal with this piece. So we're going to do this, right? Sorry about my handwriting. We're going to do this. You don't need the parentheses, sorry. So you're going to bring the 2 down and the 1 down, no parentheses. That was me just doing it too fast. Pardon me, does that make sense how I crisscross reduce there? The 1 would be here, but we just wouldn't write it. So you wouldn't need the 1 or the parentheses because you don't need the 1. So it would be Na2CO3. Does that make sense? And then here, because it's an element, I don't crisscross reduce. I Brinkelhoff yes or no. Do you remember Brinkelhoff? Okay, so this is a no Brinkelhoff, right? So then it stays as nickel, and then we have to balance it. So we're going to start with CO3. Let me clean this up so it's easier, and then we'll balance it. Actually, let me do it this way. So then we had Na2CO3 plus Ni, right? That's what we had after we had out. So we're going to look at, we have CO3 here and here. We have 3 CO3s here. So I have to put a 3 here, right? Because I can't put it in between. I can only put in front of compounds or elements. So now we have 3 CO3s on both sides. Do you see that? Yeah. And we have 6 NAs because this 3 changes everything immediately after it. So now I got to get 6 NAs. So I got to put a 6 here. right? And then I have 1 nickel and 2 nickels. Well, I can't have that. I got to have 2 nickels, so I put a 2 here, and then that one's balanced. Okay. Do you want to try this next number 1, or do you want to go back and do these after we talk and then get back on and let me know how you think? Or not even necessarily get back on, you can email me. What do you think's best for you? You want me to go through another one? You want me to go through 2 on each page? Okay, we can do 2 on each page. Let's do this next one. So this next one here, we have an element in the compound, right? So we think about that chart, looking on the decomp synthesis. It is not a synthesis because I do not have O2, because the only one that of a synthesis can be an element in a compound is if it's O2 and there's no O2 present. Questions about that are okay? Okay, so then we go, because it's an element in a compound, we go to the arrow chart. I like to call it the arrow chart. So now lithium is alone, yes. And lithium is a metal, okay? Or another way to think about this is lithium would form positives when it forms a charge. So it's going to try to replace the metal or the same charge thing on this side. So that's why Au and Li would try to switch places. So lithium has to be more reactive or higher on the chart than Au. It can't kick out ClO4 because lithium can't battle with ClO4. Lithium is a positive, it can only battle with other positives. Or lithium is a metal, it can only battle with other metals. So lithium is trying to kick out Au. Does that make sense? And it kicks it out, so then that's, yep, so then Li goes where Au was, and Au is sad and lonely by itself for a moment. That makes sense? Right, I'm kicking them out. Lithium is more powerful because it's higher, so it kicks out Au. So it goes where Au was, and Au has to go be by itself. So then I have to think about, I can't just stop there, I got to think about how does Li and ClO4 to go together. If you look on your ion sheet, Li is a +1 and ClO4 is a -1. So this would be a +1 and a -1, so they go together just like that. Don't write the ones, very good. And then, so that one's done. And then Au, is it Brinkelhoff, yes or no? No, good job. So then we're going to look at balancing next. So we look at ClO4. There's one ClO4 group on each side. So that's balanced. One Au, one Au, one Li, one Li. So for this unit, you just had to tell me it was balanced. How's that feel? Okay, so we'll go on to another example, and then you could go back and try these because when we go through these, you're going to see that there's answers on the third slide every time. So you can go back and try these if you want as practice before you take your test, or your quiz, I mean, and test. That make sense? Okay, so let's go to another type of example. So this is another set of examples. So if you can see, it says set 2, and then when I get to the third slide, in this case it'll be the fourth, there's the answers for the ones we just did. Okay, so we'll continue on this path. Okay, so now we have a new kind of example. We have a compound plus an element. Okay, so it's a compound plus element. We got to check on that synthesis decomp spot. And I don't see that it's any of those, but I'll let you check to see that, to verify that. Okay, so then we have to go to the arrow chart. Why the arrow chart? Because, or the activity series chart, because it's an element in a compound. So who's by itself is Br, yes? When I say by itself, I mean it's not with another element. That's what I mean by itself. So bromine is a lonely guy. He wants to be part of the dance, right? That's what I like to said in class. So bromine's trying to kick out something like it. In this case, bromine forms negatives, or it's a non-metal. You can look at it either way. So it has to try to kick out I. Another hint is that, do you see that Br and I are in the same column on that arrow chart? Bromine and iodine are, where bromine and magnesium are not. So in order to try to kick out, they have to be in the same column. Otherwise, they can't even go to war, so to speak. So is bromine higher than iodine? Yeah. Okay, so therefore then magnesium will go with bromine, and iodine is left by itself. Well, we don't put anything in the beginning. We write them as combinations, and then we evaluate how they go together. So we just wrote them as a combination now. Okay, so now we're going to say, well, this is a +2 and this is a -1 on my chart. If you looked on your ion chart, you'd see magnesium as a +2 and iodine's a -1. So I'm gonna put a 2 here, crisscross reduce, right? And then this is, I got to think about Brinkelhoff, yes or no, yes, right? Then you bounce it, right? And it's balanced already. 2 I's, 2 I's, 2 BR's, 2 BR's, and an MG on each side. How's that feel? Yeah, so same kind of thing for 19. So F is trying to kick out BR. F is higher, so it can. So SR goes with F, and BR is by itself. But I don't just leave them there. I got to think about what's their relationship now that they formed new ones. This is a +2 and a -1. So that's going to be a 2 there. And then this is Brinkelhoff, yes. And then I have to balance it, and it's already balanced again. Okay. All right, how's that feel? Okay. I mean, I know you probably need me to practice, but does it make sense what we're doing? Okay, so what I would say is probably the best way to handle this, and we can do some, we can always get back on and do more tomorrow or whatever. But as we go through these, you'll always have 2 left to try on your own. You can go back and I can send you the video, and then you can listen to me again in our conversation and try the next 2, and then you'll be able to see the answer when you get to the next page right here. Okay. All right, so we're going to go on to the next one, except I don't, let me go back for a second and just check to make sure it's what I think. Let's see, hold on just a sec. Let me just, yeah, okay, it was what I just want to make sure. I set this up right before we got on. I wanted to make sure I didn't do anything weird. Okay, so set 3, are we ready for this? Now, okay, so the only thing this can be is a decomp, because the only thing it can do is break down. There's only a compound. So the only option it has, because it doesn't have anybody you can trade with, right? So it's going to break down to elements that make it up. So W plus N. Okay. Then I think about Brinkelhoff for W, yes or no? No. Brinkelhoff for N, yes or no? Yes, right? Brinkelhoff, BR. So bromine, iodine, nitrogen, you know. Yes, and it's already balanced. So you would just tell me it's already balanced. So, and these 2's are on there by mistake. I meant to take them off, but that's fine. So, anyway, this would be, the only thing this can do is break down to Mg plus O. Not a Brinkelhoff, yes, a Brinkelhoff. And then I would balance it. That's why that 2's there. And then I also have to put a 2 here. So those 2's left in front are just, say that one more time. Yeah, these are the easiest ones of the whole group. I agree. That feel okay though? Do you notice how every time we do the right-hand side, we have to pause and say crisscross reduce or Brinkelhoff every time? Okay, let's go on to set 4. All right, set 4, you're gonna, again, these numbers aren't supposed to be on there. I was in a hurry and I just didn't get it done. I was trying to figure out the best way to go through this with you, but that's okay. We'll pretend like we don't see any of the big numbers in front. So in this case, the only thing I can do when I have 2 elements is combine them. So I'm gonna put Mn with O, and I probably told you on your paper that Mn is a 7 plus, because I know that's what it is based on what this is looking like. If you look at Mn on your periodic table, Mn has lots of roommates. It can be a 2, a 3, a 4, a 6, or a 7 plus. So I have to tell you which one it is, or you just get to pick one. In this case, I would have told you it was a +7. Okay, so then the only thing I can do when I have 2 elements, 2 elements, 2 elements, or 2 elements is combine them. So I combine them, and I have to think about Brinkelhoff, yes or no. So Mn is a +7 in this case, and oxygen is a -2. So the 2 would go here, and the 7 would go there. And then I would balance it. And so this would be a 2 here. I know these numbers are misleading, but I would have seen, if I didn't have this here and I didn't have this here and this wasn't here yet, I would have seen I had 2 and 7 oxygen, so I had to get them both to 14. So I would put a 2 here and a 7 here. Then that would have given me 4 MNs, and that's how I got the 4 there. Okay, that one feel okay? Can we go on to set 5, or do you want to see another one of set 4? Okay, so. Yeah, perfect. And you can always ask for help or questions as you're going. So let's look at set. So there's the answers for 3 and 4. And then here's set 5. Okay, so set 5 is back to a compound plus an element. Basically, I'm going to go through each kind that you'll get. And so as much as you can. I don't know what kind of time you have, but I can work until you're understanding or you need to go. So we have a compound plus an element here. Do you see that? Okay, so we start in that top box, the synthesis decomp box. And do you see that it is the final synthesis, XCl plus an O2? Okay, remember that X and any of that whole box, any X can have any number as a subscript with it. It's just a symbolic representation of something with that element. So XO is some kind of metal with oxygen. It could have a plus 1, 2, 3, 4, 5, 6, 7, or 8. Okay, so XCl plus, you are not, you're staying right up on synthesis because it's the last one there. Do you see where it says XCl under synthesis box? Yeah, that's the one it is because I have something with chlorine plus an oxygen. And this is our X right here. This is our X. SI is our X. That makes sense or no? Okay, so then let me get back to my pen. So then we're going to combine SI. If you look at that, what it says there, after the arrow, you're going to combine SI with ClO3. You see that? Do you see that on our formula or on our ion sheet or thing? Okay. So now we have to figure out what the charge is because remember, it's a new relationship. If you look up, you'll see that this is -1. But SI on your ion sheet can be a 2 or a 4. So I got to look and see what would it be here, right? Well, I know this is a minus, yeah, I know this is a -1 because the chlorine always has to be a 1. So this side's -4, so this has to be +4 for them to go together. So this is a +4. So then I would crisscross reduce, and this 4 would go here, and the 1 would come down, but we don't write 1. Yeah, you got to put some parentheses around. Yeah, I don't know what the lag in the video is, but or the conversation is. But yes, you put parentheses around ClO4 to separate it, and then we have to balance it. So I see, and you can't do ClO3 because it's not on both sides. So I would start with chlorine. There's 4. Do you see the 4 chlorines on this side? And then 4 on the other side, so that's good. I have 12 oxygens though, so I need to put a 6 here to balance it. And then I have 1 Si and 1 Si, and now it's balanced. Okay? You see it or no? Okay, so let's look at the next one because these are a little harder, so I want to make sure we go over more than one of these. So the next one, we have something plus water. Remember, we always look at that decomp synthesis box. Do you see that it's the second one? Okay, sorry, I forget that you don't have that right in front of you like I do. Right, so we're going to do SnO2. I'm just going to rewrite it myself, plus H2O. So then we know from the little chart there that it's going to be Sn with OH. You see that from our synthesis chart? Okay, so then but again, we can't just put them together because they're in a relationship. We got to know how they go together. We know this is a -1 because I can look up hydroxide on my ion sheet. And then to know what tin is, we have to know what oxygen is. So we know oxygen's a -2, and there's 2 of them, so oxygen's really a -4. Do you see that? Because there's 2 of them. So that means tin has to be a +4, and otherwise they couldn't go together. They have to be the same plus and minus number. So then we know tin is plus, we're going to assume tin is +4 over here, which we will do. I did a little bit of a different method when in class. I thought this might be easier to talk you through it this way. So if you just kind of think what the total negative side is, you know what the positive side has to be. Are we okay with that, or do I need to try to go through that again? Okay, so let's just look at SnO2 by itself. So if you think about SnO2 by itself, we know tin could be a 2 or a 4, right? Okay, so to figure out what it is, think of just the negative side initially and say, I know that O's have to be -2. The nice part about the negatives, for the ones we use, we always know the charge. There's no debate. So if O's are always -2 and there's 2 of them, then this side is -4, right? Because -2 times 2 is a -4. So then this side has to be +4 if there's only 1 of them for it to go together. Because I have to have a +4 and a -4 for them to form a compound. They have to be equal, the positives and the negatives. Yes or no? Okay, so that's how I know it's +4 on this side. Then I have to crisscross reduce, so I got to put the parentheses around OH and bring my 4 down. I don't know how far behind what I'm saying is coming. Do you see that now? Yes or no? Okay, so do you see how I knew that if SN is +4 on the left-hand side, then SN has to be +4 on the right-hand side. So now I know it goes +4 and -1 crisscross reduces to 1 with SN and 4 with OH. And remember, OH is poly, so I have to have parentheses around OH. Okay? Okay, so let's go to set 6. All right, so set 6 has to be a decomp, right? But it's not just 2 elements, so it has to be one of those special decomps like I have on the paper there. So do you see that? This first one is the second decomp on our list, X with an OH. Okay, so then our X in this case is going to be, oops, I gotta switch back to my pen, is gonna be CO with O plus H2O. So cobalt with oxygen plus H2O, because it's X with O plus H2O. Do you see that from the, okay, so then, but remember, we know H2O is great, but we can't just leave these guys together. We gotta think about, we know this is always a -2. And then over here, remember, if we split this and think about, we know hydroxide's always a -1 and there's 3 of them. So this side has to be a -3, right? So that makes cobalt a +3 in this case, because cobalt can be a +3 or a +2. So then I bring my +3 on this side over. And I bring my 2 down and my 3 down, crisscross reduce. How's that feel? Or how does that make sense? Okay, so then we have to balance it. So I'm going to get rid of all of my plus and minus stuff so it's not in the way and confusing. Okay, so now that's without the plus and minus stuff. Now we have to balance it. So I see that I have 2 COs, agree? Or yes, 2 COs. So I got to put a 2 out in front here, which gives me not 3 oxygens, but 6, because I got to do this 3 times the 2 here, 3 times the 2 here. I got 3 oxygens and 3 hydrogens, right? But there's 2 of them, so I have 6. So I have to get 6, so I'm gonna put a 3 here, and go from there. So now I just have to think through this one here. This one's not a quick one to balance. So we've got 6 hydrogens and 6 hydrogens. I have 3 6 oxygens and 3 let me try that again. I have 3 plus 3 6 oxygens. I have 6 oxygens, 2 cobalts, and 2 cobalts. I'll let you look at that for a moment and see if you have any questions. Let me know when you're ready to go on or if you have a question. Yes, there is. Do you see a 2 in front of that? Okay. Right. This goes through everything. Right. First you bring it through the parentheses, you get a number, so that's really 3 in here, 3 here, and 3 hydrogens, right? And then you bring the 2 through. That's how this goes to a 6 and this goes to a 6. That makes sense? Okay. Do you want to try another one of these or do you want to go on to set 7? How do you feel? Okay, let me go through and explain another one. Let's do, I'm going to do this very last one just for space in my writing. Okay, so this is a decomp also because it's only one thing that you have, right, before the arrow. So it's going to have to be a special decomp. I like to call them special. So on your list is what I mean. Do you see that it's the third one in the decomp list? Yeah. Okay, so then it's going to be nickel with chlorine plus oxygen. Does that part make sense? How I know it's nickel on the decomp list? Because when there's only one thing before the arrow, the only thing it can be is a decomp. So it's X with Cl plus an oxygen. Okay, does that make sense so far? Okay, now again, we can't just leave these guys. We know O2 is good, but nickel and chlorine have to go together somehow. So we know chlorine's a -1, and we got to figure out what nickel's charge is over here. So remember how to do that? We say, okay, I look up ClO3, and you would see that ClO3 is a -1, but there's 2 of them. So this side is a total of a -2, makes nickel a +2. Let me let you look at that for a moment and make sure you see that. So you'd look up ClO3 on your ion sheet and see that it's a -1. It's in the -1 grouping, just to help you find it. It's chlorate. And then there's 2 of them because of the parentheses. So that's how this total of a -2, which means nickel has to be a +2 for it to go together. Pardon me, which means nickel comes as a +2 on this side, yep. And then I have crisscross reduced, so the 2 comes down and the 1 comes down. Yep, you got to balance every time. So I'm going to go get my eraser. I appreciate you letting me go through this with you because I'm practicing using my pen. All right, so now we're going to balance, okay? So I've got 2 chlorines and 2 chlorines. I got 1 nickel, and I got 6 oxygens and only 2 oxygens. So I'm going to put a 3 here, and now we've got 6 oxygens on both sides. Yes, because the 2 goes through the parentheses only. So there's 2 chlorines technically and 6 oxygens. Correct. Yeah, on the right side, yes. Oh, in the parentheses, yes. That 3 is only with oxygen in the set of parentheses. Yep. Okay. All right. Next example, those are the answers for 5 and 6, and then next example is example 7. You want to jot down the first one on some paper while I'll give you a minute to do that, or a moment to do that. Okay, so this time we have, in this first one, a compound plus a compound, agree? So we always start in that same spot on the synthesis or decomp. Is it a synthesis or decomp? So you're looking for the pattern for the synthesis or decomp. It's not, agree? Okay. So then we have to go to the common gas chart, okay, to check, because it could be, the problem when it's a compound plus a compound, the difficulty, I should say, not the problem, but the difficulty of compounds plus compounds is it could be a common gas or it could just be an ordinary double replacement. So we have to check there to see if it's a common gas. Okay, so are you looking at the common gas chart? Yeah. Okay, I'm going to go back on my screen to that chart so we can talk through it so you can see I can point to some stuff. Okay, so on your common gas chart, you're looking to see if you see an ending of S2, an ending of CO3, an ending of SO3, or a start of NH4. You kind of remember that in class? Yeah. Okay, so if those are true, then you also have to have an acid plus an acid plus an acid plus a hydroxide. So those both have to be true for you to follow this pattern. So you have to have one of those 3 endings, or that start plus an acid, or that start plus a hydroxide. So if we go back to the problem, I'm going to go back on my screen. I don't have an ending of S2 minus, or an ending of CO3 in either of those, or an ending of SO3, or a start of NH4. Would you agree? So that means it's just a double replacement. So remember how to do double placement. We're gonna take the back half. So if you think about this, I'm gonna change colors for a minute. This is the front half, right? Front half, back half, front half, back half. Does that make sense? Can you see the red? Yeah. Okay, so I will want to bring over the back halves in the same order. So I'm bringing over Cn, and I'm bringing CHO2 over. Just the ions, not the plus with the parentheses part. So the ion is Cn and the ion is CHO2. That makes sense? Say that one more time. Sorry, you broke up. Yeah, bring the backs over and we're going to switch the fronts. So then we're going to put CO here and hold on, I didn't leave myself enough space here. Let me get rid of this plus sign. And okay, I'm going to put BA here. Do you see what I've done? Okay, now I can't, again, new relationship. Chemistry is all about these wonderful relationships. So we can't just leave them. We want to know how they go together. I like to say they have to, I think I teased your hour, they have to go to Dr. Phil and get the relationship evaluated. So cobalt's a +3, how do I know? Because I'd look back here and do that same thing before where I know, oh, cobalt's a +6 actually. Actually, let me look up CHO2, I can't remember what it is. Yeah, it's a 3. Okay, so this CHO2 on your ion sheet's a -1. If you look it up, it's formate. So this is a total of a -3 here, which makes cobalt a +3. So just like we did on those other problems, we have to go back. Because cobalt has a roommate, I need to know which roommate is in the relationship. That feel okay? How I know cobalt's a +3? Okay, so then I have to crisscross reduce. So this is going to need parentheses. CN is poly, even though it doesn't have a bunch of numbers with it. It's 2 capital letters. So I bring the 3 and the 1 down. Oh, okay, yeah. Never mind. I thought I misspoke, but I'm okay. All right, then barium is a +2, and that's an easy one because barium doesn't have a roommate. And we already know CHO2 is a -1 from our ion sheet. I know barium's a +2 from my ion sheet, so I crisscross reduce that one, so that means the 2 goes here and the 1 goes down. Let me give you a moment to see if that'll ask me any questions you might have before we balance. Okay, so now we're going to balance. Okay, so let me get rid of some of this stuff I used to, it'll be in the video, but it won't be here as we, so I want you to do that too, either cross off or scratch out so it's not in your way. Okay, so now we're going to balance. So I see that I have 3 CNs on the right and 2 CNs on the left, so I need to get them both to a 6. The only thing I can do is put numbers out in front, so I'm going to put a 2 here and a 3 on the left side. Does that make sense? Okay, and I have 3 and 2 CHO2, so CHO2 can be treated as a group. It makes it a lot faster to balance. So I'm going to put a 3 here and a 2 here. And then I want to check to see if cobalt and barium worked out. Now that I have 6 CHO2s on each side and 6 CNs on each side, I can see that I have 3 bariums on the right and 3 bariums on the left, 2 cobalts on the left, 2 cobalts on the right. Everything is balanced. How's that feel? Okay, do you want to do another one of these or do you think you have this one? Okay, let's go to the next set. All right, this is a combustion. Do you know how we know these are combustions? Anytime you have a hydrocarbon plus an oxygen, it's a combustion. Okay. What do I mean by hydrocarbon? Well, it's exactly what the name says. There's a hydrogen and a carbon in the formula. So a combustion is always going to be CH4 plus O2 going to CO2 plus H2O. I'm going to rewrite it while you're writing it because we're going to need to balance it. These are sometimes the harder ones to balance. First of all, does it make sense how I know it's a combustion? Okay, and then you have to memorize that it's going to be forming CO2 and H2O because it will every time. And now we're going to balance. Remember on these, we're going to leave oxygen dead last. We're not even going to deal with oxygen until the very end. So we're going to first start with carbon. So 4 carbons on the left. I got to put a 4 in front of CO2 to get 4 carbons on the right. 6. Then I'm going to leave high oxygen alone. Do you see how it's 4 and 4 now for carbon? Yeah. I'm gonna do hydrogen X. I have 6 and 2, so I gotta get 6 hydrogens. I put a 3 there. So now my hydrogens are 6 and 6, yes. So now I wanna do oxygens. So from this piece, I get 8 oxygens, plus 3 more oxygens from that piece. Do you see how I get the 8 and the 3? For oxygen, just oxygen. We already balanced carbon and hydrogen, so now we're just looking at oxygen. So 8 from CO2, because 4 times 2 is 8, and 3 times 1 for water gives us 3 oxygens. Okay, so first of all, does it make sense that carbon and hydrogen are currently balanced? Okay, so then I'm going to evaluate oxygen on the right, because what I'm going to do is I'm going to look here and say this 4 times that 2, I'm going to multiply through, right? That's 8, that's how I get this 8, right? And this 3, and there's really a 1 here, this 3 times 1, that's how I got that 3. So that's how I get, it's 11 on the right. Now I gotta get 11 on here, right? So I gotta put 5.5 here, because I know whatever I put here, I have to multiply by 2. To get to 11, I have to put 5.5 times 2 gets me to 11, yes? Okay, so but I can't leave the 5.5. We don't leave fractions and decimals until you get to a second year of chemistry. So we're going to multiply everything. We know there's really a 1 here. We don't write it. So this is going to become 2. This is going to become 11. This is going to become 8. And 3 is going to become 6. And now that's considered balanced. 2, 11, 8, 6. Everything by 2, including the very first thing, because otherwise it'd be unbalanced if you didn't. So there's always a 1 out in front there. That's why you have to multiply everything through by 2. Yeah, let me show you. Let's go through the numbers so you can see them again. So now I have 8 carbons here on the left and 8 carbons on the right. 12 hydrogens, 6 times 2 is 12. 6 times 2 is 12 here, yes? And then over here I have 22 oxygens, yes? Because 11 times 2 on the left. Over here on the right, these numbers are gone now because now I have 8 times 2, right? So I have 16 from the first set of oxygens and 6 from this set of oxygens. Something. Oh, so that's how I get 22. My brain wasn't adding that right. So 16 plus 6 is 22 and 22 on that side. The 22 oxygen on this side, on the left? Right, correct. So 16. Because we need to, I'm showing you we have 22 oxygens on that side also, because 16 plus 6 is 22. Right, 22 here and 20. I'm showing you that that's how we got 22 oxygens on both sides. That okay? All right, let's go on to set 9. So 7 and 8, there's answers there, and then set 9 is this one. Okay, so on set 9, I'll let you write it down. I'm going to write it down also because it gives me a little bit more space to show stuff. Okay, you ready? So we have a compound plus a compound, yes? So we got to start in our synthesis decomp box, and we should observe that it's not any of those. So we'll take a moment to observe that, because I don't have a CO2, H2O, or an O2. I know this has been long, but we're almost through. And then you can practice and let me know what else you need help with, okay? But do you see how it's not a synthesis or decomp? So we have to go to the common gases, because it's either a common gas or just an ordinary double replacement. So remember, our common gases have to end in sulfur or S, CO3, SO3, or start with an H4. I have an ending of S, don't I? And I have an acid, so it's a yes and a yes. Do you see? So then it tells me on my sheet. So look at your common gases sheet. It tells you it forms H2S plus and a salt. So it says forms H2S gas. You don't have to worry about the state of matter plus a salt. Our salt is going to be a front that we haven't used. So do you see we haven't used Mn that was in the front? So every time a salt's the same way. It's something from the other side that was in the front that you haven't used yet on this side, and something on the other side from the back that you haven't used. So what have we not used from the other side in the back position? Yep. So that they'll go together as the salt. That's how you do the salt on all three of these, or all four of these actually. But we can't just put it together. We got to think about how it goes together, right? So we got to think about the charge. We know this is a -1. So thinking about the charge, I'm going to switch colors just to help you see. So over here, we know sulfur's a -2 times 3 of them. So this is -6, right? So Mn has to be a 6, but there's 2 of them. So I'm going to think about 6. So this has to be a +3, because then 3 times 2 for this would give me a +6, and I'd have my two numbers the same. So then I know this is a +6 on this side, and I can now crisscross reduce it. So I'm going to bring my 6 down like that, because the +6 comes over to the other side. This is probably the hardest part of all this, in my opinion, just knowing the charges. Okay, that feel okay? Now we just have to balance it. So I see I have 6 chlorines and 1 chlorine, so I'm going to put a 6 here. Now I have 6 hydrogens, right? Yep, 3 there, which gives me 6 hydrogens and 3 sulfurs, 3 sulfurs. But I need 2 manganese. Something's not right. Why does it feel weird? So I'm going to put a 2 here, but then that's going to give me 12 hydrogens. Sorry, 12 chlorines. So then I got to put a 12 here. Okay, so then that gives me 12 chlorines. Something's not right, because this shouldn't be. I'm missing something. This feels weird. Hold on, let me just think about this for a second. Actually, I'm just going to cheat and go look at the key because to save us time. Where is it? There it is. I said it was a +3. I thought that was. Oh, you know what I did? I messed up. I'm sorry. I know where I got myself. I got myself confused. So this should be a +3. This is a +3, not a +6. And that's because, and I don't give you these very often, so don't stress over this one. This is the hardest one probably on all of these. But that's because I would have to get a +6. I do 2. This is a +3. So this is actually a 3 here. So let me go through that again. Let me just clear my, let me clear my screen and I'll go through that again with you. Sorry about that. HCl Mn2S3. I did that math differently than I've been doing with you guys, and then so this would be Mn and Cl. So then what I should have said over here is this is a -2 times 3, which is a -6. Over here, I know I have to get a +6, and I have 2 times what would get me to +6, a 2 times a +3. So this would be a +3 over here. So then when I n a -1, so this would be a 3 like that. Sorry about that. I didn't go through that properly. It's a different way of teaching it. Usually I make you reverse crisscross, but I wanted to see how that felt because I thought maybe it'd be easier, especially when I'm not there with you. Okay, so let's go through and balance this again. So now we have 3 chlorines, and we're going to put a 3 here. So that gives me 3. I'm going to leave hydrogen till the end. I got 3 sulfurs, so I'm going to put a 3 here. I need 2 Mn, so I'm going to put a 2 there. So now I've just messed up my chlorines. I need 6 chlorines and 6 hydrogens. So instead of putting a 3 here, we're going to put a 6 there. Again, you will not have anything this difficult on your test or quiz. This is probably one of the hardest ones, period, that I give you guys. So let's do one more of these if you have time, just because that one was kind of blah. Is that okay? Do you have time? Okay, so I'm going to clear my screen, but it'll be saved in the video. And then let's try that next one. If you want to jot that number 32 down, we'll go through that one next. Oh, yes. When I was deleting earlier today, I got a little too crazy. Yeah, there should be an arrow up there. Okay, so do you see this is also a common gas because it's not a decomp? And what do we have? We have a CO3 ending, so we got to check, and we have an acid. Remember, acids start with hydrogen. So then we know it's going to form CO2 and H2O, right, based on the common gas sentence. You see that? Plus the salt. Remember how to do the salt? What front have I not used yet? Good. And what back have I not used yet? Awesome. Nice job. So these are great. CO2 and H2O we know are perfect. We just got to get these two set together. So we're thinking about this as a -1. And I'm going to change colors just for visual effect here. So I'm going to split this and say I know this is a -2 times a 2 because there's 2 of them, and I know CO3 is a -2 on my ion sheet. So this side has to be a -4. So that means TC has to be a +4. So this is +4 here. So then I'd have to put parentheses around this and bring my 4 down. That makes sense? And now let's balance it because now everything's good. So I see that I have 4 CLs. Do you see? So I need 4 CLs on this side. So I'm going to put a 4 here, which gives me 4 H's. So I need 4 H's over here. So I put a 2 there. Now my H's and CLs look good. My TCs are good 1 to 1. But look at my carbons. I have 2 carbons here. Do you see? So I need to put 2 over here. Now I have 2 carbons on this side. So everything looks good except we haven't checked oxygen. So let's look at oxygens. We have 6 oxygens here, so 3 times 2, plus another 12. So that's 18, right? 6 plus 12. 6, this is 12 here from the front piece. 4 times 3. Okay, plus 6 more is 18. So over here we have 4 from here, plus 2 from here, plus 12 from here. This is supposed to be a plus sign. See the 4 from CO2 oxygens? 2 plus 12 gets us, this is a plus, which gets us to our 18. Right? Yeah, so that's balanced. Okay? Okay, so again, if I continue forward, you'll see here in a second that I have answers for you. Okay, this next set is just a repeat of what we've done already. So that actually, I think, gets us through. Okay, so I will. Do you have any specific questions at this moment? Okay, so work on some and let me know. And I have spent most of my day yesterday, and I built the quiz and the test will be go through Schoology. You'll still have to take pictures of your work for this part of the quiz, but the other part of the quiz where you're balancing and classifying, or I'm sorry, on the test. On the test, you're going to balance, classify, and do this. On the quiz, you're just doing this. So you will be able to do the test on Schoology, but you will need to be able to take a picture of this part of your test and your quiz and upload it as part of your grade in Schoology so I can see your work. That's how I'll grade it. So when you're ready, I can push it out and you can have the whole day to work on it. You know, it'll be timed, but you can start it whenever you want. Once you feel like you're ready, I'll open it and you'll have about 24 hours to get in and take it. And the quiz will take, you'll get 45 minutes on the quiz and you'll get an hour on the test. So you just need to let me know when you're ready. Okay, I think I did. I'll double check though. If not, I will get them in sometime this afternoon or early tomorrow. But just don't hesitate to reach back out if you're working on these and you're not getting good answers. And on some of, on some of these, I accidentally left the numbers in front. So just ignore any number in front, balance it yourself. I tried to get them all out, but I didn't. Does that make sense? Okay, please don't hesitate to reach back out. So because I want you best prepared for that, but we do need to get that done by Thursday evening because I have to upload those grades Friday. Okay, you're welcome. Talk to you soon.